You need to prove that this is a trapezoid. Whenever you're trying to prove a quadrilateral is a trapezoid, you have to go back to the original definition. The definition states that it's a quadrilateral, 4 sides, 4 angles. Check that out. But it's a quadrilateral with exactly one set of parallel sides. So we've got that. We just proved that segment DE is parallel to segment AC, so that's good. But now we have to show that the other pair of opposite sides are not parallel. Well, that's obvious because these two lines intersect at point B. So there's no way they can be parallel to intersect at point B. So I've shown that this is a trapezoid. Now I need to show that it's an isosceles trapezoid. That was given to us. Segment AD is congruent to segment CB. So yes, this is an isosceles trapezoid. But you would have to state all 3 of those things to prove that it is an isosceles trapezoid. And then it says explain, this is part E, angle ADE is congruent to, I'm running out of colors here, so it says that this angle here, ADE, is congruent to which angle in this diagram? And why? CET. What's the theorem, postulate, or property that backs that up? What's our explanation? Let's just someone walk me through it. Let's see it.
Well, DEC and ECA have to equal 180 degrees.
Tell me the angles again. I'm sorry.
DEC and ECA.
They do have to equal 180 degrees. So why does that prove that this angle is congruent to that angle? So yeah, these have to be supplementary, but how does that prove that these 2 angles have to be congruent?
Because A and C have the same measurement.
So you're saying that since these are supplementary, those are supplementary, and then these 2 base angles are congruent, and these have to be the same measurement? Cool, yeah. It's called the congruent supplements theorem. And it states that if you have 2 angles that are supplementary to the same or congruent angles, then they have to be congruent. So there's a couple of ways of looking at it. You can look at these 2 linear pair and say, well, since this is a linear pair and that's a linear pair, and these 2 supplements are congruent, that means that the other part has to be congruent as well. Or you can look at how Kevin looked at it as these 2, the fact that these 2 pairs of consecutive angles within that trapezoid have to be supplemented. But it comes down to that. It is the congruent supplements theorem. So make sure you are aware of that theorem, the congruent supplements theorem. And so the grand conclusion that we are looking for is, if your trapezoid is isosceles, then you've got these angles that are always going to be congruent, and you also have these angles that are going to be congruent. And in a trapezoid, those 2 special sets or pairs of angles are called the what angles in trapezoids? Those are your 2 pairs of base angles. So if your trapezoid is isosceles, then your 2 pairs of base angles are always going to be congruent. And that's exactly what it says on part F on page 211. Page 211, part F says complete the theorem. The base angles of an isosceles trapezoid are congruent. That's both pairs of base angles. Bless you. Both pairs of base angles are congruent. They're not congruent to each other like the 2 different pairs of base angles, but within each pair. Item 8, we don't have time to work it out, but remember, again, I've told you this last class, that if you're trying to prove that a quadrilateral is a trapezoid, you have to show that 1 pair of opposite sides are parallel and the others are not. You can't just show that 1 pair of sides are parallel and stop there. If that's all you show, that doesn't tell you anything. You could have a rectangle, a rhombus, a parallelogram, a square, a trapezoid, etc. You can't just stop there. Gotta go back to that definition. I do want to talk about item 9 really quick at the bottom of 211. This just is talking about why the diagonals of a isosceles trapezoid are congruent. And so we're telling you right here that this quadrilateral is a trapezoid. So from that, I know that these lines are parallel. Then it tells you that segment CO is congruent to segment ER. So that means that this is an isosceles trapezoid. And then we want to prove, we're trying to conclude that segment CR is congruent to segment EO. Please add the bar up above the capital E, capital O. We're talking about congruence, we're talking about segments here. So segment CR is congruent to segment EO. And if you look at the diagram, that's just, you're trying to prove that the diagonals of any isosceles trapezoid are congruent. What we're going to have to do is prove that there's two overlapping triangles in this diagram. We're going to prove that they're congruent, and we're going to use CPCTC. So if we look at this triangle here, and then this triangle here. Now you may be asking yourself, well, Mr. Niven, how did you know to choose those two triangles? There's a bunch of triangles in there, and how do I know I'm supposed to choose those? If your end goal is trying to prove that these two segments are congruent, then you need to pick two triangles in the diagram where these are corresponding parts. So that once you prove those triangles are congruent, then you can say, okay, since those triangles are congruent, then all of the other corresponding parts have to be. So these two triangles, the red and the green, have segments CR. That's the long segment in red, and it's corresponding to segment EO in those two triangles. So that's how I knew to choose those two. Those are the only triangles in that diagram where those segments are corresponding. So now I look at my information and say, okay, well, how am I going to prove that these two triangles are indeed congruent? Well, I know right off the bat they have the two legs of the trapezoid, that those are congruent. That was given to us. So this is our first information. Remember, you must have 3 pieces of information about two triangles to prove that they're congruent. Yeah, there's 5 ways: side, 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 angle, angle, side, or HL. So this is our first piece of information. Our second piece of information is that they share a segment as well. These two triangles share segment OR. So I'm going to say that segment OR is congruent to itself. That's justified by the property of the reflexive property of congruence. And now we need a third piece of information. We just got done talking about how isosceles triangles have congruent base angles. So if I look at this angle here and that angle there, that's a set of base angles. And in isosceles triangles, I'm so sorry. In isosceles trapezoids, the base angles are congruent. So I could say that angle COR is congruent to angle ERO. And that would be justified by base angles are congruent in isosceles trapezoids. Now these two triangles are congruent because of side, angle, side. Once I've proven that the two triangles are congruent, then I can use CPCTC to prove that these two segments are congruent. So again, that may pop up on a quiz or test. Know how to prove that the diagonals of isosceles trapezoids are congruent. That will always be true. Okay, which takes it to page 212, which was your homework. So I think, I mean, this is my recollection, that right before you guys left last class, I said, hey, when we got through the median theorem, and then I said that the base angles of isosceles trapezoids are congruent, so I just kind of said that as we were packing up. But I really wanted to go through it and kind of pick apart all of this stuff. So do you have any questions on the homework from page 212?
Number 10, part C.
10 part C. we're given that quadrilateral PLAN is an isosceles trapezoid. Use the diagram below, and the properties of an isosceles trapezoid define each of the following. So it says write an equation and solve for x if the length of AP is equal to x, and the length of NL is equal to 3x minus 8. Well, those are representing the lengths of the diagonals, and the diagonals are congruent, so the two segments are congruent and the lengths are equal. So you're going to have x is equal to 3x minus 8, and you're going to get that 2x is equal to 8, so x is equal to 4. That's what it asks for, is asked for the value of x. X would be 4. You know that those two segments are congruent. The diagonals of all isosceles trapezoids are congruent to the lengths of each. Next question. 12. Item 12, we were given that segment EF is the... Are you serious? Sorry. They're calling it a mid-segment. Anyways. Yeah, whatever. This is a mid-segment of isosceles trapezoid, a median. Okay, we're just going to have to go with flow here, guys. All I can do is apologize at this point. So... This is the mid-segment. They called it the median earlier, but it's connecting the two midpoints of these trapezoid legs. It also tells us that this is an isosceles trapezoid. So let's just take one variable at a time. Let's figure out what x is first. So x is representing the length of this median, this mid-segment. And so that length, EF, is the average of the two base lengths. So it would be the length of AB and the length of DC. So just plug in the expressions that are representing these segment lengths. So I got 2x equal to 1/2 times the sum of 10 and 8x minus 43. So I'm going to get that 2x is equal to 4x, and this is going to be 33, so that's 16 and a half. Sweet. Subtract 4x from both sides. I'm going to get that 2x is equal to this negative 16 and a half. And so this is going to be a positive 8 and a quarter. 8.25. This is 8 and a quarter. Someone get some coffee. So x is 8.25. Now let's figure out what y is. Erase this so I can see. So 2i plus 3 is representing the length of this segment AE. We don't know what the length of the segment ED is. We don't know the length of the segment BF is. And then FC is the length of, as being represented by 6y minus 1. Well, since both of these expressions have y involved, we got to figure out some way to relate them. Now, they told us that this was an isosceles trapezoid. That means that these legs are congruent. So segment BC is congruent to segment AD. Well, this is the median of the trapezoid. So that means that E is the midpoint. So that's congruent to that. And then F is the midpoint. So this is congruent to that. And I can put one marker of congruency on all of those because if the wholes are congruent, then the halves are congruent as well. So that means 2y plus 3 is equal to 6y minus 1. And when you solve, yeah, that's it, right. When you solve y is going to equal to 1, and from there you just plug those values back into those expressions. Let's move to the other page, 221. Any questions or concerns on page 221? Remember, I'm going to give you the answers, so don't ask a question just because you want to see what the answer is. You're going to get those. We need to spend time on explaining problems that you don't understand, not just, hey, did I get it right? I heard 3 first. What part of number 3? Part 3, we're using the median of a trapezoid. We're using that theorem. So again, the median is 1/2 the sum of the two. So if I'm doing part A, HJ, this is 40, PQ is 28, and we don't know GK.